Okay, very first example that we're looking at for the review. Has a x squared part, so we're doing something like x squared equals 49, and they ask you to solve it. It says to simplify your answer as much as possible. Okay, so for this one, just square root both sides. And then you've got x equals, and in this case, it says solve for the real number, and it says if there are more than one solution, separate them with commas. So for this one, they're wanting both answers. So it would be 7 and negative 7. Okay, the only thing on this one that you have to be a little bit careful of, we'll call this 1a here, is if you have x squared equals to a negative number. If you try to square to a negative number, now it's not a real answer. It would be complex or imaginary. So if you square a negative number, that's the part that you would have no solution. So on the first question, that's pretty much the only thing. You're either square rooting a positive number, give me the two answers. If it's a negative number, it's going to be no solution. All right, problem number 2. Pretty much the same kind of thing. They just change up the variables on this one. So it's y squared equals 121. Same thing with this one, just square root both of the numbers. So for that one, you get y would equal 11 and also negative 11. Okay, number 3. First one, you have to do a little bit of work with it, because on number 3, I have something like x squared equals 120, where it's not a perfect, again, just changing that one number where it's not a perfect square root, you're still going to square root both sides. So the biggest thing on this one is you have to take the 120 and break it down. And when you start to break this one down, you can, again, there's all kinds of different ways you can get to 120, and it doesn't matter how you want to get there. If you can think of a perfect square root that would come off of 120, you can do that right off the top of my head. I can't think of one, so if I do that, I'm going to start breaking it down, and I'm going to start with 2, because that's the small. You want it in smallest terms if you can think of it. Sure, you can do 10 times 12 and break those down, but be careful because sometimes it's easy to leave another prime number when you're going through the factor tree. So I would say keep it small. Do 2 times 60. That becomes 2 times 30. That becomes 2 times 15. And then the 15 becomes 3 times 5. So if you break 120 down, that's 1, 2, 3 2s, 3, and then a 5. Okay, so you have the one pair of 2s, so that 2 would come out. Everything else you're left with on the inside doesn't have any pairs, so you've got 2, 3, and 5 left on the inside. Those you just multiply together. So 6 times 5, so that's 2 squared to 30. And it seems like you should be able to take more out of it than that, but that's it. And because we're square rooting it, again, you're going to have 2 answers. So you're going to have 2 squared to 30. Then you also have the negative 2 squared to 30. So sometimes you get a big number that looks like you could take it and break it apart, but really it was just the one pair that you could take off that one. They may do the same thing on that one. If that had been a negative 120, no solution. So they may still throw the negatives at you when you're going through those. But it's still the same situation there. Okay, number 4. Same question, just different numbers here. Let's go with x squared equals 48. Keep this one a little bit smaller. Again, just square root both sides. So for that one, you're just taking the 48 and breaking it down. And for that one, to me, I'm thinking 16 times. Now, again, you could do 2 times 24, but 16 times 3, if you go with that one, you've got a perfect square root of the 16. Take the square root of 16, you make that 4, and then the 3 is left on the inside. So x could be 4 square root of 3, also could be negative 4 square root of 3. Okay, now it doesn't happen much, but let's just kind of give you 4a here. If you had something like x squared equals 15, if you square root both sides, if you get something where it's square root of 15 and there's nothing, you can break it down as 5 times 3, but you don't get any pairs of anything. If you get one like that where there's no pairs of anything you could break out, then for that answer would just be square root of 15 and then negative square root of 15. May not happen, but just on the chance that they give you a number that you're not able to break it down and take any pairs out, that still is a possibility with those. So I guess you have 4 possibilities. Either you have a perfect square root where it comes out to be whole numbers. You have one where you can break it down and take out parts of it. You have another one where if you break it down, there's no pairs you can take out. And then you also have the negative numbers where if you square the negative number, it's no solution. So same problem you get there, but there's 4 different answers, I guess you could say, that you could possibly run across when you go through those. Okay, the good news is on these questions, they're all exact answers, so we're not going to worry about any decimal numbers. Okay, and then number 5 kind of steps it up a notch here. That for number 5, we've got x plus 7 squared minus 45 equals 0. And same directions on this one. Use the square root property to get the answers. Okay, so for this one, very first thing you want to do is get rid of the 45 and move it over to the other side. So you have x plus 7 squared equals 45. Okay, and once you've got the x plus 7, in this case squared, that's the whole thing you want, is that you want to get the squared term by itself. Once you've got the squared term by itself, then square root both sides. Okay, so when you square the square root, that part goes away, that'll leave you with an x plus 7. When you square root 45, that part you've got to break it down a little bit, and for the 45, I'm thinking 9 times 5 on that one. And if you do that, you've got a perfect square root with a 9. So then you can make that 3 square root of 5. Okay, now here's the thing with this one. When you're doing this part of it, when we square root the 45, you've got the positive, you've got the negative. So it's almost one of those cases where you almost have to do it twice. That you've got x plus 7 would equal 3 square root of 5. At the same time, you've also got that x plus 7 would equal negative 3 square root of 5. So to solve this one, you would subtract 7 from both sides. So then you got negative 7 minus 3 square root of 5. And for the one on the right here, when you subtract 7, x would equal negative 7 plus 3. square root of 5. So it's still that same thing of just making sure that you remember that when you square root that number, you're still going to get two answers. The 3 square root of 5, one time it's going to be positive, one time it's going to be negative. Okay, so everything through those first 5 questions, it's all just square root property. The last one there, number 5, that's the first one where you have to do a good bit of work to it. Everything else on the first 4, you're just square rooting it. Whatever the answer you get, that's the answer you get, unless it's negative. You know, if it's negative, then we had no solution. All right, number 6 changes gears a little bit. For number 6, this one you have to use the quadratic formula. And this one, again, it says give the exact answer, so no decimal numbers on this one. Just leave it in square root form when you're going through these. So we have 5x squared plus 9x plus 2. Okay. First thing is, you got to have the a, b, and c values, and as long as it's in descending order, a is in front of x squared, the b is in front of x, and the c would be the last number that's at the end. And from there, you're just going to plug everything into the formula. Okay, and there's our formula. Okay, and the one piece of information when you're plugging numbers in is I would say every time you plug in the A and the B and the C, now in this case they're all positive, so it's not that big a deal, but if you have negatives, sometimes that makes them a little bit, what's the word we're looking for there? A little sticky sometimes when you're going through those. So just to be on the safe side, anytime you plug in a number, I would say put a parentheses around it. So that's negative B or negative 9 plus or minus 9 squared minus 4 times 5 times 2. And that's over 2 times 5. Okay, and almost all the work is inside the square root because you got the minus of 9, so that part's just a negative 9. Bottom part, you've got 2 times 5 for 10. And all the work's going to be on the inside, which is what they call the discriminant. 9 squared is 81. 4 times 5 is 20 times 2 is 40. So that's 81 minus 40. Or square root of 41. Okay, and for this problem, they're going to ask for the exact answer. And if you start breaking 41 down, it's prime. Nothing you can do to break that part down. So to me, that's an okay answer. Now, we don't have the plus or minus button on your calculator or on the homework. So for this one, we're going to have negative 9 plus the square root of 41. And since there's nothing you can do to simplify, there's no fractions here to simplify, put that over 10. And then negative 9 minus the square root of 41 over 10. Now, just on the chance that something does simplify, they should have you, which they don't for this one because nothing simplifies. If you write it like this, I'm okay with that. Just let me know if you go back and do it that way because I'll have to go back and check it. The reason I would say to do this is that on the chance that you do get something in here that simplifies, if you leave it here, which is the way the homework would tell you to do it, you may not see those numbers that would simplify, where if you break it up in separate parts, you know, if this had been a 5 or an 8 at the beginning, well then you could take this 8 over 10 and simplify that part. If you don't split up as two fractions, sometimes you may miss that. So this is one of those that if you want me, I will probably go back and double check it anyway. But for that question on the test, just just to be on the safe side, I would say break it up as two separate fractions. All right, let's get one more of those. Let's go with 4x squared minus 6x plus 1. Still using the quadratic formula on this one. Okay, so we plug it in. It's minus negative 6 plus or minus square root of negative 6 squared minus 4 times A times C. And all that's over 2 times 4. So minus negative 6 means that's a positive 6 or just a 6 there at the beginning. So we know there's a plus 6. Really, we don't need the plus, so you can take that off. Just leave it at 6. Negative 6 squared is 36. 4 times 4 is 16. Minus 1 is still 16. Over 8. So that's 6 plus or minus 20 over 8. Okay, and for this one, different than the other one, when you break down square root of 20, that one does have some parts you can break off of it. That if you take 20 and break it down, you can make it 4 times 5. And with the 4 times 5, you can take the perfect square root of the 4. So we really can make this 2 square root of 5. Okay, now for this question, if you don't break it up into parts, if you leave it as one big fraction like that, or leave one as 6 plus and the other one 6 minus, that part, they're going to count that wrong. Because when you break this thing up, if you don't break it up, then you would not see the fractions that you have here with the 6 over 8 and the 2 squared of 5 over 8. And we'll do the other one with the minus here. Okay, and because you've got 6 over 8 for that part, you can make that 3 over 4. And then we've got the plus. And with the 2 over 8, same thing, you divide those both by 2, that would be square root of 5 over 4. So that would be the first answer. The second answer is going to be the exact same thing, we're just going to change it to the minus. Good. Now, and to me, they ought to make it so that all the answers are the same. So on that first one, I would say go ahead and break it up into 2 parts. And I'll go back and check it. If they count it wrong, then I'll go back and make sure that, you get the full credit for it. So I would say go ahead and take everything with quadratic formula, break it up into separate parts, because there's a good chance, right now 50-50, that you're probably going to have to simplify a little bit when you do break those up. Okay, number 8, still quadratic formula, but this time it tells you to round your answers to the nearest hundredth. So this is the first one that you don't want to have decimals in the answer, or square roots in the answers. So for this one, let's go with 9x squared minus x minus 2. And your ABC values for this one, A is 9, B is -1, and C is -2. Okay, and plugging everything in, we've got minus -1 plus or minus -1 squared minus 4 times A times C. And all that is over 2 times A. Okay, so we'll change the minus negative to just a regular 1, 2 times 9 for 18. -1 squared is 1. 4 times 9 is 36, times 2 is 72, so that's 1 plus 72. Which is 73. Now, with the decimal part on this one, this is one where, because they ask for the decimal in the answer, you don't really care about if this thing breaks down or not because you don't need it. So for this part of it, you just got to do the square root of 73 and get that number. Now, when you do that, make sure that you go more. I know it says round the answer off 2 decimal places, but that's the final answer. So I would say when you're punching in square root of 73, or whatever the number is, go 4 decimal places, because at the end you've got to have extra numbers to round off. So when you do the square root of 73, take it a couple extra numbers or a couple extra places. So if you square root 73, that is 1 plus or minus 8.544. Next 2 decimal places are 0, so we really don't have to have the 0 because it won't really impact it there. So I know it says 2 decimal places, but go more than that because you want to round it off at the end. Okay, so doing the 2 parts. We're going to do 1 minus 8.544 over 18. So if we do minus 1, that's 7.554 divided by 18. So we divide that by 18, and I'm getting that that's 0.419, so that would make that about 0.42, negative 0.42. Okay, and then the same thing, but this time we'll add to it. So square root of 73 plus 1 divided by 18 should be 0.53022, so that's about 53. Okay, so there would be your 2 answers in decimal form. And again, I guess the good thing with the decimal form is you don't have to worry about breaking down the 73. Just punch it in, take it to 4 decimal places just so you've got more to round off, and then split off into 2 parts where one time you're going to add and one time you're going to subtract that square root. All right, one more quadratic formula. But for this one, it tells you you're going to have complex roots. So A is 3, B is 6, and C is 1. So we're going to go negative 6. Plus or minus square root of 6 squared minus 4 times A times C. Okay, and I could be wrong, but that does not look complex, does it? Okay, so let's do this. Let's make this change so that the C value, because that's going to be 36 minus 12, that's 24. That's going to be a positive, so that's not complex. I'm taking this right off the practice test. So let's change that last number. So instead of being 1, let's make that 4. Because to me that's a trick question if they tell you to find the complex roots, but then give you a problem that doesn't have complex roots in it. So let's change it so it is. Alright, so we've got negative 6 plus or minus square root of 36 minus 48 over 6. Okay, so for that one, we do get a negative inside the square root there. That's negative 12 over 6. Okay, so two things with that one. Because of the negative, we know we're going to have I in the answer. So if you want to go ahead and do that first, you can go ahead and take that negative out. And I think they're having the answer at the end of it. So where we've got the negative, let's take the negative out and put an I on the very end of it. So that's over 6. And then we'll take and break down the square root of 12. With square root of 12, you can make that 4 times 3. And when you square root the 4, that would make it 2 square root of 3i. Okay, and similar to the last one, where you've got the negative 6 over 6. We've got the plus or minus 2 square root of 3 over 6 and the I trailing behind it. That part, again, if you break it up as two separate fractions, well, now you can see that you've got a negative 1 in the front, and then the 2 over 6, you can make that square root of 3 over 3. Okay, so your two answers would be negative 1 plus the square root of 3 over 3. With I trailing behind it, you could also have negative 1 minus square root of 3 over 3 with the I trailing behind it. Okay, and then one last question. Got a graph y equals 2x squared or negative x squared, or whatever it is anyway. Just graphing one part of the basic graphic. We've got to plot the vertex and 4 additional points, 2 on each side of the vertex. Okay, so for this one, and everything that we did, if there wasn't anything added or subtracted to the tail end of it, the vertex was always going to be at 0, 0. The only time that you would change the vertex from being something other than 0, 0 was if they add or subtract some number at the end. If you add or subtract some number at the end of it, that's going to move it up or down. But there's nothing that we added or subtracted to this, so the vertex automatically becomes 0, 0. And to get your points, they say 4 points. You really only need 2, because if you move 1 space to the right, that's going to be the same answer as if you move 1 space to the left. Because if you plug in 1, x squared is, well, it's 2 times 1 squared. 1 squared is 1, so that's just 2 times 1, which would be 2. If you plug in -1, it's still the same thing. So it's also 2. So there's your first order pairs. You got 1 at 1, 2. And if you move 1 space to the right, it's going to be the same answer as if you move 1 space to the left. Same thing for 2 and -2. If you move 2 spaces to the right of the vertex, it's going to be the same answer as if you move 2 spaces to the left. So if you plug in the 2 squared, 2 squared is 4, and 2 times 4 is 8. It'd be the same thing if you plugged in the -2. Okay, so if you had to plot the graph, first point would be at 0, 0 because that was the vertex, and everything else after that, we said we had the point 1, 2, -1, 2, 2, 8, and then -2, 8. So it's over 1 up 2. -1, 2 would put us here. And we're going to 2, 8, and -2, 8. Okay, and again, the number that's in front of x squared, the a value, or if we're doing the quadratic formula, that tells you the direction the graph should go. In that case, the a was positive. And if a is positive, that means the graph should point up when you get finished with it. If that had been a -a, the graph's going to point, or what they call open downward. So that first point, the first value, tells you the direction it's going to go. If it's positive, arrows are pointed up. If it's negative, arrows have to point down from your vertex, which, again, in most cases on these, it's going to be at 0, 0.